So we're talking about inverses. Inverse. All right, to begin with, what is an inverse? I don't know if you remember, but an inverse is something that gets reflected over this line. So if I'm trying to reflect sine over that line, sine, kind of goes like this. Something will only have an inverse if it passes both the vertical and horizontal line tests. Does sine, in this little zone that I just did, does it pass both the vertical line test, which it does pass the vertical one, but it doesn't pass the horizontal one, does it? So in order to have sine have an inverse, this is kind of a stretch, but they limit sine to only being this part of sine between here and here. And in that little zone, it passes both the vertical and horizontal line tests, right? If it does, then sine can have an inverse there, and we call it inverse sine. It's like this. Now, what is this good for, the inverse of sine? What is it good for? Well, it only works in this little zone between pi over 2 and negative pi over 2. And here's what it's good for. Question or comment, or what do you think? What do you think it's good for? Okay. Mm-hmm. That was incredibly intelligent. Very good. I'll just roughly translate and say that in physics you have a formula that uses sine, and if you want to rewrite that formula to just have the angle alone, you'd need inverse sine. And that is exactly right. So let me give you an example of how you are going to see this. It's going to be as simple as this. Inverse sine of, and then they give you something that they want the inverse sine of. I'm going to give you a simplest one. It would be like this. Inverse sine of a half. What this really means is they have rewritten the problem to ask this same exact question as that I'm about to write in red here. If they had written this, you would have understood that they were saying sine of what angle is equal to a half. The blue is the exact same thing written a different way, where the variable theta is now like over here. I could say equals theta, right? So basically, this one is solved for theta, and this one is not. How about this? If I wanted to take the red one and solve it for theta, I'd have to get theta alone, right? How do I get rid of sine? You use inverse sine. That's what it's good for. It's sort of like matter and antimatter. They're not supposed to come in contact with each other, or all heck breaks loose. Multiply and divide cancel each other out. Add and subtract exactly cancel each other out. Sine and inverse sine cancel each other out. So you can go like this. I'm going to do inverse sine on this side, inverse sine on that side, and the sine and the inverse sine cancel each other out. And now I just have theta is equal to inverse sine of 1/2. Well, it still hasn't answered the question. The question is, what is this angle? And that's what you have to do for your homework for today. So if the problem were like the blue one right there, I would do 3 steps in my process. First step I would do in my process would be to rewrite this as a normal sine problem. Not every teacher does this, but I really think it helps, and I'll show you why in a second. I would write this as normal sine of theta is equal to 1/2. And now here's the next part. Do you agree that this little all students take calc has come in handy to help you figure out where things are positive and negative? Like all of them are positive here, only sine's positive here, etc. Well, now you need to know another one of these. Remember how I showed you how inverse sine was only allowed in certain places? You're going to put this down in your notes. Inverse cosine is only allowed from here to here. Okay? Inverse cosine is only allowed in the S and the A categories. If you look at cosine, do you agree that cosine's like a big valley, kind of like that? would you agree that cosine will pass the vertical line and the horizontal line test if I go between those two dotted lines? Passes both vertical and horizontal. That's why cosine is only allowed, inverse cosine, sorry. This inverse cosine here is only allowed between 0 and pi. See? Between 0 and pi. So inverse cosine is only allowed from there to there. And inverse sine, I showed you before, inverse sine is only allowed like this and then down like that. It's only allowed in there. So we're going to make yourself a new little chart. Another thing to memorize. Inverse sine is only allowed from there to there. And tangent happens to be the same. Tangent and sine have the same rules. All right, so in answering this question, you asked me some clarifying questions, which I'm going to erase now. My first step in the process is to rewrite it as a normal sine question. And then I wouldn't draw all of this little chart, but I would remind myself the ASTC thing, and I remind myself, where is sine allowed? Inverse sine. Inverse sine is only allowed. I'm going to use my Neato highlighter here. Where is it? Remember that button. I just color it in yellow. Okay. Sine, inverse sine is only allowed here and there. And where is this, or what is that red equation telling me? That sine has to be positive. Where is sine positive? There and there. Do you get how they overlap in quadriplane? Therefore, my triangle needs to be drawn in that quadrant. Now I draw my triangle. My triangle is a normal old triangle with sides opposite, hypotenuse. You recognize that one? 1, 2, and what's the other one? We're at 3, and therefore what angle is this right there? 30. So the answer is 30. But it could have been 2 answers. But there wasn't, because it only would work in that spot. All right, let's do another one from start to finish. Let's say you had inverse sine of root 3 over 2. Okay, what is the point of this again? It's just a different way of writing it. See, theta's alone if you write it this way. But what I would do if I were you is rewrite it the way you're used to, where the angle's supposed to be here. Sine of some angle is root 3 over 2. There, that's my first step. Next step. Nope, because it's not inverse sine. This is normal sine. This is inverse sine. Okay. Next, I'm going to try and figure out where this is allowed. Where is inverse sine allowed? Do you remember? There to there, right? Okay, so inverse sine is allowed there and there. All students take calc. Therefore, it can't be here and it can't be here. You get that? All right, and sine is positive, so therefore it can't be here. So it must be here. And now, sine of some angle. Sine is opposite or hypotenuse, opposite root 3, hypotenuse 2. What's the angle across from the root 3? 60. 60 degrees. Now, if they want it in radians, you just have to know it's pi over 3. That's all there is for today. Nice, easy stuff. You just have to rewrite it once. Know this new rule about who can remember, where's tangent allowed? I'm just going to call them A, S, T, and C. Where is tangent allowed? A and C, good. And where is cosine, inverse cosine allowed? S and A, yep. And where is sine allowed? A and C. That. Okay, and then if they had said sine is positive, well, right away I would know that it has to be, can't be here and it can't be there. And if they said inverse sine is positive also, if inverse sine is positive, actually, if inverse sine is, if it's an inverse at all, I'm allowed to be here and here. Either one of those two. And if sine is positive, I could be here and I could be here. You can't have 2 answers. That's cosine. You're right. I did that wrong. I'm going to say that again. If sine, I'm going to give you a sine, inverse sine of 1/2. If sine is positive, which it would be, then I am ruling out this spot and this spot. I did that right. And then if inverse sine is what we're using, we're only allowed to be in this little zone, and we just ruled this one out, so that means it has to be right here. We can only draw one triangle. I can tell you on today's, just to avoid pain and suffering, there aren't any that are going to give you two answers. You'll only have single answers for all of these. Yes? Could you repeat that and let me try to understand it? Ah, is there ever an answer in the third quadrant? Is that really kind of your question? Well, there can't be an inverse sine in the third quadrant. You've made a good observation. If you have an inverse sine and you try to do it over here, the answer would be undefined because it's not allowed. You can't have one. So if I ask for the inverse sine of, what's something that's over there, 200 degrees, that would be undefined. Maybe there isn't ever a way to have more than one answer on this one. Okay. Okay. Cool. Well, as long as we don't break any rules, you'll only have one answer on all your problems today. All right, so let's do these right now. We'll start this together. And then once we're into it well enough, it'll be lunchtime. And then when you come back, I'll give you your test. Yes. It's still just trig. You're just into a next part of trig. I get what you're saying. You're probably right. I just hate to make never statements because they're so often wrong. And it seems like there's always an exception to the rule. Okay. I really believe in having a step-by-step process. So, here's your first step. Mr. S, let me turn around and start this thing, number 1. It's inverse sine of root 3 over 2. I think we just did that one, but let me show you how I would want you to show it. First step, you don't have to do this. It really is optional, but I kind of like it because it tells you something you're used to. The normal way you'd write it is sine of theta is root 3 over 2. Sides are supposed to go over on the right. But when you do inverse sine, the sides are right up next to it, kind of like backwards. Now I'm going to make my little thing here where inverse sine is only allowed in A and C, only A and C. So I'm going to rule out this and rule out that. Okay, and where is sine positive, like it is right here? Only right there. Okay, so it must be in the little box, can't be here. So now I'm going to draw myself a little picture. And I have sine is opposite of hypotenuse, right? Opposites root 3, hypotenuse is 2. Must be across from the root 3 angle, and is 60. And you wouldn't really want to say 60 though because it says in radians. See, it's about. There we go. All right. Now, it does say specifically no calculator because it is as simple on the calculator as you type in inverse sine. There's an app for that. There's a button for that. The inverse sine of root 3 over 2. And it just tells you. Okay, so you could get. It wouldn't actually tell you pi over 3. It would give you some weird decimal. It's include a pi over 3. But it would give you a decimal. Well, that's if you had it in degrees. Since pi over 3 isn't. Oh, wait, no, it would give you 60. It would say 60. It would say 60 degrees if you were using a calculator. Or if you set it to radians, it would give you a weird decimal. Okay. So, I don't know, do I need to do more? Let's do one more. I think number 5. People are going to wonder, what the heck is this arc cosine? Imagine back in the day that their calculators, or sorry, typewriters, had to use like negative exponents. You get how that'd be a pain in the butt? What if there was just another way to say inverse cosine than to have to write this? What if you could do it all on one line? You can. Arc cosine means the exact same thing as inverse cosine. So when they say arc cos, that just means inverse cos. All right, so inverse cosine of 1/2. So it's just like this. This is number 5 now. And it's got the theta all alone. It doesn't even show it, but you could say equals theta. There's no variable in this thing. Then you could rewrite it like I like to. Cosine of theta is 1/2. And then you have cosine's only allowed here to here. And A and S, you could say, in quadrants 1 and 2. And then cosine's only positive in one of those two, right here. So therefore, I've got to draw my triangle there. And then cosine's adjacent over hypotenuse, adjacent hypotenuse is 3. And what angle do we have right there? Is the answer always pi over 3? That it is again. Okay. So, I think you agree that this one's on the easier side, which is good. Just had a long, painful, cumulative test, and I'll be giving those back to you today. It shouldn't have been that painful, mostly because I keep looking at these and going, you only got one right, and yet I'm giving them a 70%. That's pretty generous. So they're coming out pretty good, partially because of that. But many of you got a minimum of an 80, which is pretty good. So the vast majority of the people are average AB or better on this test, which is better than some of our tests, that's for sure. Okay, that's all I got for the video for today. Okay, I'm actually adding one more thing. Problem number 4 on the homework, I know a lot of people are going to get confused about because they won't be able to draw a triangle, but it's still the same basic process. Step 1, well, I'm writing down the problem, actually. That's not really even step 1. Then step 1 would be to rewrite this puppy as cosine of some angle is equal to 1 over 1. And I should realize at that point that I can't draw a triangle when adjacent and hypotenuse are the same size. It must be one of those, one of those problems where the answer is either here or here or here or here. That brings up an interesting question. If you're allowed to be, inverse cosine is allowed to be from here to here. No, wait, that's not cosine, that's sine. Sorry, inverse cosine is allowed to be from here to here. And cosine has got to be positive because of this. So if cosine is going to be positive, that means that it can't be here. So now I'm down to just drawing my triangle here. Wait a minute, I can't draw a triangle. But then my choices are either here or here. And of these, x over r, where is the x equal to 1? This spot or this spot? And I think you know. What comma what is that spot right there? 1 comma 0. What spot is this right here? 0 comma 1. Which of them has an x equal to 1? That one. So what's the answer? 0 degrees. If you want to do it in radians, 0 radians. Just 0. Yes, it's less work to make a radian because you don't have a degree symbol. Yes. Could you call it 2 pi? No, because that's outside the zone. And it is lunchtime.